Alright, so firstly, when we're doing this question, I've got to remember to leave things where I put them. When we're doing this question, the first thing we need to know is how this system works. Okay, so we've got a jib, as you can see here. It's kind of like a crane arm. And it's joined to the wall with what is a pin joint. Right, so that's a pin joint. It's not able to support any kind of bending. It just supports either tension, pulling it out from the wall, or compression, pushing it into the wall. Okay? This is a tie. A tie is like a cable, and that's also a cable that would be going around the pulley to support the 900 kilogram weight. Because it's a cable or a rope, they can only support tension. So that means that the two forces that are happening from the wall is a compression force. I'm going to label my forces in blue. That is pushing up at the pulley, and we're going to look at what's happening at the pulley. And a tension force that is pulling away from the pulley. And then finally we've got our weight force here. So we're going to label them. So force jib, force tie, and force weight. Now, what we need to know before we can make we can make a 3-force diagram, but it's not going to have any angles yet. So this is where this question gets a bit tricky. So what we need to do is we need to calculate our angles to be able to put them into our force diagram. So the angles that we need to know are, I'm going to colour them, put them in red because they apply to both. So the angles, we're just going to call one theta. Need to know that one. We'll call this let's go alpha, and we'll call this one x. I don't know. Doesn't really matter what we're calling them. All right. So this is a non-right angle triangle, which means we can't use right angle trig. We only know sides, so we can't use the sine rule. So we're going to be using the cos rule, the cosine rule. So let's write that out. So cosine, cos rule. And the way that you normally see that is c squared equals a squared plus b squared minus, I'm going to move this out of the way until I need it, 2ab times cos c. Okay, so if we were trying to find theta, then this is going to be our C angle, which makes 5 meters our C side. But to find the angle, first we're going to rearrange this equation. Okay, so we want to get C all on its own. This one here, not that one. That already is on its own. We want to get the angle C all on its own. So what we can do is we can take away our a squared and b squared. So we'll get c squared minus a squared minus b squared. We'll just minus them because they're plussing at the moment. Equals negative 2ab times cos c. Cool. And then our negative 2ab is timesing our cos c. So we can divide both sides by negative 2ab, negative 2ab. Cross those out. So we get c squared minus a squared minus b squared over negative 2ab equals cos c. So now to find c, we use the inverse cos rule. Inverse cos. So the inverse of cos, and we put everything else in it, so c squared minus a squared minus b squared over negative 2ab. Cool? And that will be our angle C. Now we can use that to find either theta, alpha, or x, doesn't matter. We just need to pick what our sides are. So let's use it to find theta. So theta equals cos to the power of negative, inverse cos. So we now need to use our side that's opposite our theta, 5 squared. The other two doesn't matter which order they're in, so minus 4.5 squared minus 8.5 squared for our other two sides, all over negative 4.5 times by, negative 2 times by 4.5 times by 8.5. Okay? We can put that into the calculator. So, shift cos, big brackets, big fraction, 5 squared minus 4.5 squared minus 8.5 squared over negative 2 times by 4.5 times by 8.5, close brackets. Let's see what we get. 28.07 degrees. So we're going to put that in, and we'll round it to just 28, and we'll put that into our triangle. Okay? Now we can do the exact same thing to calculate alpha or x. We don't need to rewrite it in our calculator, we can just change our sides. So let's do it for calculating x. So x equals cos negative 1. Okay, so now if we're calculating x, our c is going to be 4.5 squared minus a and b doesn't matter which order they're in, 5 squared minus 8.5 squared over negative 2 times by 4, times by 5. This is where you've got to be careful that you're not just copying what you had above. Times by 8.5. So x is going to equal, so we can just edit our what was in the calculator. So we want 4.5 squared minus 5 squared minus 8.5 squared, that's good, over negative 2 times by 5 times by 8.5 equals. So that equals 25.06 degrees, and we're just going to put that as 25 because it's quite close. So 25 degrees. Okay. Let's make it now what we've found obvious, theta and x. And then we could do that again to find alpha, or we can just take it away from 180 because the angle sum of a triangle is 180. So 180 minus 28.07 minus 25.06. Probably didn't need to put those decimals in. 126.87, so we'll round that up to 127. So alpha equals 180 minus 28 minus 25 equals 127. Alright, so we found our three sides there. Our three angles. So now we can use that information to make our 3/4 triangle. So I'm going to draw that now. So we're going to take it from our point at our pulley. So the first one we know is 900 kilograms, which is 9,000 newtons. Okay, so let's draw that on. So there's our starting point. Pulley, going to go down 9,000 newtons. The force is going to be going up at the same angle that the jib is going up. Okay, so we're going to go up at 28 degrees, and we don't know how big that force is yet. And then with our alpha is going to be the same, 127. And it's coming back. We'll use that. Okay, so we can put our angles into this. So we've got 28 degrees, that's the same. And 127 degrees is the same. And 25 degrees. So our angles stay the same, it's just our magnitude. Which has now made me think of a really easy way to do this question. Oh well, live and learn. Okay, so now we've got that. We'll label our sides, so we've got force jib, force tie. Okay. So now we can use the sine rule, or you could use the cosine rule. I always go for the sine rule if that's available to me. So I'm going to move this up. So to find Fj. So remember the sine rule. Is A over sine A equals B over sine B equals C over sine C. So Fj over sine 127 equals, we need to put in our known one, so 9,000 over sine 25. So our unknown is Fj, so we can times this whole side by sine 127. So Fj equals sine 127 times by 9,000 over sine 25 equals sine 127 times by 9,000 over sine 25 equals 17,007.6 newtons. Seems like a lot, but makes sense because it's holding it out at quite a distance. Alright, and then we can do our Ft in the same way, force at the tie. So that equals sine 127 times by, sine Ft, sine 28 times by 9,000 over sine 25. Again, we can just change the one number that needs to be changed. Calculator, so sine 28, and that equals 9,997.8 newtons. Alright, and I actually feel like this would probably work out quite nicely. It's probably actually, if you didn't do any rounding errors, it would probably equal to 17,000 newtons and 10,000 newtons, is my guess. And while I was doing this, I just thought of a really easy way to do it. I want to see if anyone can have a guess at what that might be. Post your easy answer. It's actually to do with, oh no, I won't tell you. I want to see how you go, and I'll let you know tomorrow if no one's had any luck. Alright, hope that helps. Send me an email if it doesn't make sense, and I'll try and help you further.